It's now time to take a look at control flow statements. So when a program is run, the CPU begins execution at the top of main. It executes some number of statements and then terminates at the end of main. The sequence of statements that the CPU executes is called the program's execution path, or just simply path for short. So most of the programs we have seen so far have been straight line programs, and straight line programs have sequential flow. So that means they can take the same path, execute the same statements every time that they are run, even if the user input changes. However, often this is not what we desire, and for example, if we ask the user to make a selection and the user enters an invalid choice, ideally we'd like to ask the user to make another choice. So this is not possible in a straight line program. And alternatively, there are cases where we need to do something a certain number of times, but we don't know how many times at compile time. So for example, if we wanted to print all the integers from 0 to some number a user entered, we couldn't do that until we know what number the user entered. So fortunately, C++ provides control flow statements, also called flow control statements, and these allow the programmer to change the CPU's path throughout the program. So there are quite a few different types of control flow statements, and we will cover them briefly in this video and then in more detail throughout the rest of the course. So loops, these cause a section of your program to be repeated a certain number of times. The repetition continues while a condition is true. When the condition becomes false, the loop ends and control passes to the statements that are following the loop. So some examples of these are the for, the while, and the do while loop. Decision making is about deciding the order of the execution of statements. These are based on certain conditions or repeat a group of statements until certain specified conditions are met. And some examples of decision making in C++ are the if, the else if, and switch statements. So now let's take a look at some examples of how we can use loops and decision making to control the flow of our program. Now, how many times a loop is executed or whether a decision results in the execution of a section of code depends on whether certain expressions are true or false. So these expressions typically involve a kind of operator called a relational operator, which we've looked at in previous slides, and this compares two values. So since operation of loops and decisions is so closely involved with these operators, we're going to examine them first. Now, if you remember a relational operator, and I've put them here in our comment section for quick reference. Basically, a relational operator compares two values. Now, the values can be any built-in C++ data type, such as your char, int, float, double, etc. And they can also be used for user-defined classes. So the comparison involves such relationships as equal to, less than, and greater than. And if the result of this comparison is true or false, then we will be able to make one decision based on true and a different decision based on if the answer is or the result is false. So let's write a program that performs three kinds of comparisons between 10 and a number entered by the user. So these three comparisons will check whether the number entered is less than 10, whether it is greater than 10, or if it is equal to 10. So first, let us declare a number, and then let us prompt our user to enter a number. And then we are going to store that entry into our num variable. All right, now we're going to do a series of checks. So first we're going to check if the num entered is less than 10. And the program should tell us if this is true or false. Now in C++, this may be shown as a 0 for false and 1 for true. So let's do, so inside of these parentheses is where our checks will be done. So num less than 10. Put in an end line. So now let's check if it is greater than 10. So let's evaluate if the number is greater than 10. And thirdly, we'll evaluate if the number is equal to 10. And if you use the double equal sign, this will tell whether or not it is equal or not. It will perform that operation on the number. Remember, a single equal sign means that you're assigning the value on the right to the variable on the left. So we're checking if the number is equal to 10. Okay, and now we can run our program. Control F5. So I enter a number. If I enter the number 10, right? So we see here the number less than 10 is 0, number greater than 10 is 0 or false, and number equal to 10 is true. So it evaluates to a 1. Okay, so let's try our program one more time. So if I enter 5, we see here that the number is in fact less than 10. And if I run my program one last time, and let's say I put 13, you can see here now that it evaluates to true when my number is in fact greater than 10. So I implore you to remember that the equal operator uses the double equal sign, as we can see here, equal to. And right here we're using the equal operator as well. So a common mistake is to use a single equal sign, and like I said before, the equal sign is the assignment operator. So if you use a single equal sign, this will cause a really nasty bug in your program and it will just error out. So even though the compiler may not notice anything wrong, your program will not do what you want it to do, except maybe, you know, out of sheer luck. So remember to use the double equal sign when you're doing comparing if something is equal. All right, so now let us take a look at an actual loop. So I'm going to begin with the for loop. So this is one of the easiest loops to understand, and all of the control elements of this loop are gathered into one place. So the while loop in some other types of loop constructs, these control elements are scattered about the program, and it can make it a little bit harder to unravel how the loops work. So let's look at a for loop that executes a section of code a fixed number of times. All right, so in this demo, we will do a for loop that displays the squares of the numbers from 0 to 14. All right, so let us first define a variable, and let's call it j. And now in our for loop, we are going to define our conditions. So for j, we're now assigning the value of 0 to j. As long as j is less than 15, we want to increment j by 1. All right, so now let me do a cout, and we're going to cout whatever j is at the time of the iteration, and we're going to multiply it by itself. And let's put a little space here. And then finally, let's cout an end line after each one of these. And then that should be enough. Let me not forget my semicolon here. Okay, so to recap, we created a variable, integer called j. And now in our for loop, inside our parentheses, we are doing our comparisons, and we are setting up our control elements. So here we're assigning the value of 0 to j. Here we're saying if j is less than 15, we should increment j by 1. So this plus plus tells us to increment by 1. And if it was minus minus, this would mean to decrement by 1. Okay, so let's leave that there. So now let us run our program. All right, so we can see here that we have printed all the numbers between 0 and 15, and given the square of that number. So 1 times 1 is, of course, 1, 2 by 2, 4, 3 by 3, 9, 4 by 4, 16, and so forth till we get to 14. And then once the program realizes that j is now more than 15 or equal to 15 in this case, then it then terminates the loop. So that's an example of a for loop. So to quickly recap, we have our initialization expression where we initialize our variable. Then we have our test expression as long as j is less than 15. And then we have our increment expression. And then this for loop is a single body statement, so we don't really need a curly brace here. However, if our loop had several more statements, then we would definitely want to enclose it inside curly braces, for instance. So it will look something like this. And then this would be the end of the for loop. So if it's one statement, you don't necessarily need your curly braces, but if it's multiple statements, then you definitely need your opening and closing curly braces. Let's quickly take a look at another example of a for loop, and in this situation we will be finding the cube of a number, but instead this time we're going to do it with a little bit of formatting. And I would like to introduce the IoManIP library in this video and show you how it can be used. So the IoManIP is part of the input-output library in the C++ standard library, and this helps us with certain precision functions and setting of width, and basically it can help us to format our program, our results, to let our program look a little bit neater. So for this, I will need to include the right. Okay, so now I am just going to jump straight into my for loop, and here's another way you can define your for loop. You can actually define and declare your variable inside the parentheses. So we can say int number equals to 0. So we can do it like that also. So we can say num. Now I'm going to use less than or equal to 10. And then we're going to increment this by 1. I will be opening up my curly braces so that I can see where my function body, or not my function body, my for loop starts and ends. So first I'm going to see out, and I'm going to use the set width. Okay, so this is going to work on our stream here. So I'm going to set this width to 4, and we're going to display the number in that column, and we're going to say now int, and the cube will be equal to this number times itself, right, 3 times. So now I'm going to do a cout. I'm going to set this width to 6. And in this column, I will be printing the cube. And that should take care of it. Okay. So now for a quick recap, we have defined and also assigned a value to our integer here of number. Here we are setting up our test once it is less than or equal to 10, and then here we are incrementing by 1. We're using a special function from our IoManIP library, and we are simply setting a column width to 4 and printing the value of num in that column. Here we're creating a variable to store the cube of our number, and then we are creating another column with a width of 6 to display that cube result in. So now let us run our program. Okay, and there we have it. So starting from 0, 1, and then we can now see the values. The cube of 2 is 8. 2 times 2 is 4, and 2 times 4 is 8. The cube of 3, 3 times 3 is 9, and 3 9s 27. So you can see it is printing the cube for each number in the loop up to number 10. So the reason it included 10 in this is because we changed this relational operator from simply less than to less than and equal, less than or equal to 10. So therefore our number increments all the way up to 10. So let's now take a look at the while loop. So we see here that the for loop does something a fixed number of times. But what happens if you don't know how many times you want to do something before you start the loop? So in this case, a different type of loop may be used, and we can take a look at the while loop for this example. So in this example, we're going to have a while loop, and this is going to ask the user to enter a series of numbers. And when the number 0 is entered, then the loop will terminate. All right. So remember, there's no way for us or the program to know in advance how many numbers will be typed before 0 appears. So that is up to the user. So we have to define our code to be able to accept multiple values and terminate when a specific value is entered. All right, so let us first set up our variables as we usually do. So I'm just going to say int n, and I'm going to set it equal to 99. And this should be actually our while loop. So now we can say we'll use our keyword while and then our condition. So n is currently 99. So while n is not equal to 0. All right, so we want to enter that value into n. Then we want to do a cout and just print a new line here. Okay, so this loop should run until a user enters the value 0. So simple as that, you have a loop. So let's test it. Okay, so I didn't use a prompt this time, so it's just waiting for me to enter a number. I've entered 469, any number. Once I enter the number 0, then our loop terminates. So the while loop may look like a simplified version of the for loop, and it actually contains the same kind of text expression, but in this case, you're not able to initialize it within the parentheses. All right. So first, you have to define your variable, and then you have your text expression, and then you can have either a single statement body, or you can also have a multiple statement body, as in the for loop example as well. So in a while loop, the test expression is evaluated at the beginning of the loop. And if the test expression is false when the loop is entered, the loop body won't be executed at all. And in some situations, this is actually what you want. But sometimes you have to guarantee or want to guarantee that the loop body is executed at least once, no matter what the initial state is of the test expression. So when this is the case, you should use the do loop or the do while loop. So let me change this. And we're going to do an example with the do while loop. So let's remove all of this. And we're going to define some variables. So we're going to do, in our do while loop example, we're going to invite the user to enter two numbers. So a dividend, which is the top number in division, and a divisor, which is the base number in the equation. It will then calculate the quotient, which is the answer, and the remainder. So we're going to be using the divide and modulus operators. So right, the modulus operator is simply a %, and this gives us the remainder. So if you divide 10 by 3, 3 will go into 10 3 times, remainder 1. So modulus in this case would only give us the remainder, which is 1. So let us define some variables, and we're going to use long. Right, so we're going to have our dividend and our divisor. Right, and if I hadn't told you before, you can define multiple variable names in one line, simply separating them by a comma, as long as you'd like them to be the same type. And we're going to use a char, and we're just going to call our char ch. So in our do while loop, we begin with the do statement. Right, so first we are going to prompt the user So have them enter dividend. And right away, we are going to store that value in our dividend. Oh, I need to spell it correctly. That's why I could not find it. Next, have them enter our divisor. Do a C in. And then we're going to print the quotient. So we can say here, that the quotient is, and we're going to do our dividend divided by our divisor. And then we're going to simply say, we're going to append to this statement a comma and say remainder is, and then we're going to say dividend, and we're going to now use our modulus operator, and okay, let me okay, so now we're going to actually see out a prompt. So we need to ask our user, and let's throw this into a new line. Let's ask them if they'd like to do another, and simply type yes, or Y for yes, or N for no. Right, and then we're going to see in this value into our char character. So let me spell this properly. Okay, so now once we have entered that value into our char character, we come out of the body of the do while body. Then we specify our while statement. So we want to say while character is not equal to no. So we would like to continue our program. All right. So it kind of does things in reverse. So this guarantees that the program will at least run once and then do a check. So you choose in your coding which loop would work best for you. If you need to execute the statements at least once, you would want to use a do while loop. If you would like to do the check before you execute anything, you could use the while loop and for loop, of course. So let us now run this program. So let's enter a dividend. So let's enter 18, and our divisor, let's enter 9. Quotient is 2, and the remainder is 0. Do you want to do another? And by our logic, as long as you do not enter no, it should run the program again. So 1 second here, let's see something. Okay. Oh, I see what the problem is. I'm using the wrong slash, so it should be \n for the new line. So let's run this again. So let's enter another dividend, 15, and then let's enter 7. Okay, so the quotient is 2. 7 goes into 15 2 times, and the remainder is 1. Let's do one more. Yes, let's enter a dividend. Let's enter 100, and we want to enter, let's enter 8 as the divisor. So 8 goes into 100 12 times, and the remainder is 4. And let me now enter n. And you see that our program has now terminated because we have met, we have entered n and met that condition that causes our loop to terminate. So those are essentially the types of loops that exist, and you decide the use case for each one of these loops, if it fits for what you're trying to use it for. So now let's take a look at decisions in program. Take a look at the most basic kind of conditional branch in C++, and we know this to be the if statement. So an if statement takes the form of if expression and then statement, or it can be if expression followed by a statement. If that statement is true or false, then we could have an else that would allow us to do something else based on that evaluation of true or false, right? So it can otherwise be called a conditional expression, and true would be anything that is not a 0, and of course false would be a 0. So let's use or look at a simple program that utilizes the if statement. So first thing, let me prompt the user. Okay, so we're going to ask our user to enter a number. Let us define a variable called x. We usually do that first. It doesn't matter as long as it's defined before we enter the value into it. So here we have cin, and we will put our user value into x. Now let us do an evaluation of x. So we can use our if statement and open up our parentheses, and we can do a check to see if x is greater than 10. All right, so keeping it really simple. So if x is greater than 10, we're going to see out, and we're going to print that value and say is greater than 10. And let's throw a new line in here. So that's our if statement. So if x is greater than 10, that will be printed, and then we can say else, and we can see out or print another value. X is not greater than 10. So there you have it, a very basic if statement. Let us run our program. So if we enter the number 11, we get 11 is greater than 10. Let's run it again. If we enter 7, 7 is not greater than 10. However, we are missing one check. So let's say we entered the value of 10. We would still get 10 is not greater than 10. So in this case, we'd actually want to print that 10 is equal to 10. So we need one more condition added to our if statement in order to check for if the value is equal. So in order to do this, we can do it with multiple if statements. But before we do that, in this scenario, we are using a single statement block. So if, for instance, we wanted to enter a second statement block, so let's say we wanted to simply print you entered and X. If we wanted to have multiple statement blocks between our if and else, we would get an error if we do not use our parentheses. So if it's a single block, you don't need a parentheses or curly braces rather. But if your statement has multiple lines or blocks of code in it, then you definitely want to use a statement block. So let me clean that up and add my curly braces. It even makes for better reading of your code. So there we go. So we have our if and our else. So we have to do one more check to see if 10 is actually, or whatever number is entered is actually equal to 10. And in order to do this, we need one more statement. So let us use an else if statement. So we'll say if X, and remember we do the equal check using the double equals. So if X is equal to 10, we will simply say you entered so we're going to say is equal to 10. All right, so that should check for all three conditions. So now let us run our program again. And let us check with 10, right? You entered 10 and 10 is equal to 10. And it should work just fine for the other. For the others, 4 is not greater than 10. And lastly, you entered 44 and 44 is greater than 10. So that's a pretty basic example of our if-else statement and how we can check multiple conditions, and based on whether or not a condition is true, then our program may perform different tasks. Now let's look at another example using some more logical operators. So let's remove that for now. Actually, I am going to keep my prompt. All right, let us remove it here. So this new program is going to use multiple conditions in one if statement block. And of course, we'll be using our logical operators. And what this program will do is check to see if both integers that are entered are positive, or if one of the numbers is positive and one is negative, or if neither of the numbers entered is positive or negative. All right, so in order to do this, let me remove this space, and I am going to just do a quick copy and paste. So I'm going to prompt the user twice to enter a number. First number will be stored in X. The second number will be stored in Y. So now we're going to do a check based on the numbers entered. So we can say if, and now in our parentheses, so if X is greater than 0, and we want to do the check for Y at the very same time. So we can do that using the double ampersand operator. So and Y is greater than 0, and we're going to open up our statement block. We want to print both numbers are positive. All right, so that's our first check. Our second check will check if one or the other number so is positive or negative. So else if x is greater than 0, and to do an OR check we need the double pipe like that. So that's what is called a pipe operator. Okay, and I'm finding my pipe operator. I press the shift key and it is directly above my shift key and to the left of my enter key. So I'm not sure where on your keyboard your pipe operator may be, but that is what it should look like. So we're checking to see if x is greater than 0 or y is greater than 0. Then we can say one of the numbers entered. Right, so one of the numbers is positive. We're just going to keep it really simple. And then to do our final check, we do an else and we just open up our body. We can say cout. So if both numbers entered are negative, then we can just assume that we can say both or neither number is positive. Okay, so let's give this program a run. So let's double check. We're creating our prompt, variables, entering that value. Okay, so let's control F5. So if I enter 4 and 5, both numbers are positive. If I enter 9 and -7, one of the numbers is positive. And if I were to enter two negative numbers, and of course we get neither number is positive. So again, you see here how we can do multiple checks in one if statement block. All right, so remember your logical operators is what will assist you in able to be able to do so. All right. Okay, so I have one final example I would like to do with our if-else statement. So our if-else statement can also be used within a function block. So if I wanted a function that simply returned the max number out of two numbers, I can do that within a function call. So let's create a function that returns an int, and let's call it min, or let's call it max. And it's going to take two integers, x and y. And in this function, I am simply going to say if x is greater than y, then I'd like to return x, else return y. Let me not forget my semicolons. Right, so pretty much that's all there is to it. So my function signature is an int. I'll be returning an int. The name of it is max, and it has two parameters, x and y. So inside my function, I'm doing a check right off the bat. if the arguments that are passed in the numbers that are passed into this function, if x is greater than y, then we want to return x. So obviously if x is not greater than y, then y is automatically going to be the max number. So we return y. So let's not forget our function prototype. Okay, so let us say we just need the function signature. So it takes 2 integers. So that's our prototype. And then in our program, let us create 2 integers, a and b. And then we'll say a is equal to 6 and b is equal to 75. So we have just created 2 variables that we are going to pass in as arguments into our function call. So now let us call our function and let us create a variable to hold the result. So we can say int result equals, and we can say max, which is the name of our function, and it takes 2 parameters. So we're going to enter a and b as our parameters, and the result will store the value or the max number that's returned from this function. So let's just do cout the max number is, and let's say result. Okay, so let's run our program. Right, so of course we get the max number is 75. And if we change a, let's say to 602, and we again run our program, the max number is 602. Right? So there you have it. And if you, let's say you wanted the user to enter these numbers. So let's just look at how we do that really quick. So we just simply ask our user to enter first number, and then once they enter the first number, we're going to do a cin and store it within a, and we can delete this, because as you can see, I've already declared a and b at the top. So then I'm going to prompt the user again, enter second number, and I'm going to do cin and store that value in b, or variable b. All right, so that's all we need to do to have an interactive program. So let's run it. So my first number will be 75, my second number will be 321, and it will let us know that the max number entered is 321. So you see the building blocks of programming as we're going along. You can pretty much do anything that you can think of, or any solution can be created with C++. You just simply, once you know how to do loops and make decisions and create functions that you can reuse in your program, you will be well on your way. All right, so let us now take a look at some switch statements. The switch statement is also a multi-way selection statement and is similar to else if in functionality, and frequently used keywords along with switch are case, break, and default. So here I've included a little example of the syntax that is used in a switch statement. So you have the keyword switch, then your expression to be evaluated, then in your function or program block, you have different cases. So you can have as many different cases as you need. So you have case, and then the first value, then the code to be executed if that first value, the condition is met. And then of course your break statement, which is very important because if you did not have this break statement, then the default code would always be executed. So this break statement here is very important. So you need to remember to include it. So after you have all the different cases, then of course there will be a default code that would be executed if all the cases are not matched. So in this example that I'm about to do, I am going to create another interactive program where a user can enter a character. All right, so we will be using char for this, and we will let our user know if the character they entered is a vowel or not. So if we know what the vowels are, we have A, E, I, O, and the U. So therefore we should have 5 different cases, and of course our default. So let us get to it. So we're going to define a char called ch. We're going to prompt our user to enter a character. Then of course we're going to store that value in ch. And now we can begin our switch statement. Okay. So remember, the first thing we need is the actual switch, and I press tab and it pretty much created that for me. So what will be evaluated, or the expression that will be evaluated here, is of course the character. So I need to enter that variable. So that is what we will be checking throughout this switch statement. So we already have our default statement, and let us define what our default statement will be. So if none of the characters entered are a vowel, we of course want to say, let us say cout, and then our character, and let us say is not a vowel. And we drop an end line there. Right, so that will be the default action. So if we go back to our diagram, of course, default comes last. So we need to have our cases now. So let me enter that down. So the first case, so I'm going to use the keyword case, and we're going to start with A. So we know that A is a vowel, and we need our semicolon, and we will print cout okay. Actually, let's just include this in a text, because if they do enter an A, we can simply hard code here. A is a vowel. And then, of course, let's not forget our break statement. Okay, so the next case And I like to make sure that I am keeping my format here. So E would be our next case. So if it's E, let's say cout E. E is a vowel. So case AE, now time for I. Oh, typing. So let's say I is now we are looking for O. O is a vowel. And I believe we're at our final case. So if it is a U, and let's not forget our break statement. All right, so that looks like it. So just to recap, we have our switch statement here. We are checking the character that is entered by our user, and we're checking to see if that character is equal to any one of these cases that have been defined. So we're looking for vowels. So the vowels are A, E, I, O, and U. And if this character, this local variable, matches any of these characters, then it will print this message. And if it doesn't match any of them, then we'll simply get our default output, which states that our character is not a vowel. So let us run our program and test it. So enter a character, P. P is not a vowel. Let's run it again. So let us now enter O. O is a vowel. Okay. And we see that our program is working. If we enter E, E is a vowel, and I'm sure it will work for any character. Z is not a vowel, right? So there you have it, an example of a switch statement, and you can definitely sometimes substitute it for an if-else statement. Sometimes there are specific use cases that would make more sense to have a switch statement instead of doing, you know, more than 4 or 5 different else if statements. Once you get to about 4 or 5 if else statements, then you'll probably want to consider using a switch statement in that case. All right, so that's it for switch statements.